we're going to prove that n choose 0 minus 1/2 n choose 1 plus 1/3 n choose 2 minus dot 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 plus negative 1 to the n over n plus 1 times n choose n is equal to 1 over n plus 1. The hint that we're given is the left-hand side of this equation, right, is equal to this. And then we're going to use the identity that, remember we've proven this in a previous video, but instead of n plus 1, it was up to n. But of course, this works for any n greater than or equal to 0, so of course it'll work for n plus 1. So we're going to use this in order to show that inside of the brackets is 1, because if this left-hand side here is equal to this expression here, right, then inside of the bracket must be 1 in order for this side to be equal to 1 over n plus 1, right? So we're going to show this equality using these two as hints, right? So let's go ahead and get started. So proof. Okay, so let's go ahead and start with n choose 0 minus 1/2 n choose 1 plus 1/3 n choose 2 minus dot 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 plus negative 1 to the n over n plus 1 times n choose n. Okay. All right, so we're going to express these, right, in terms of the factorials and everything. So this will be n factorial over 0 factorial, n minus 0 factorial, minus 1/2 times n factorial over 1 factorial, n minus 1 factorial, plus 1/3 times n factorial over 2 factorial, n minus 2 factorial, and then minus dot 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 plus negative 1 to the n over n plus 1 times n factorial over n factorial, n minus n factorial. Okay, so now, as you can see, I want to get 1 over n minus, or 1 over n plus 1, right? So I'm going to factor it out of these terms, okay? So this is equal to 1 over n plus 1, okay? So if I do that in all these terms, this is going to be n factorial times n plus 1 over 0 factorial, n minus 0 factorial, because I took out an 1 over n plus 1, so I need to have this n plus 1 on top, so it's still the same thing, right? And then minus 1/2 times n factorial times n plus 1 over 1 factorial, n minus 1 factorial, and then plus 1/3 n factorial, n plus 1 over 2 factorial, n minus 2 factorial, right? And then minus dot 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 plus, and here I'll have negative 1 to the n over n plus 1 times n factorial times n plus 1 over, this is going to be n factorial times n minus n factorial. And you'll see why I kept the 1 over n plus 1 here. Okay, so now I can rewrite this as 1 over n plus 1. Okay, so here I know 0 factorial is the same as 1 factorial, because so I'll have n plus 1 factorial, because n factorial times n plus 1 is n plus 1 factorial, over 1 factorial. You can see where I'm going, right? And then I want n plus 1, right, minus 1 factorial. So I can get the n plus 1, right? N plus 1, choose 1, right? Does that make sense? Okay. And this expression is the same as this here, right? And then minus. So n factorial times n plus 1 is n plus 1 factorial over, and then 2 times 1 factorial is 2 factorial, right? And then this will be, I can rewrite this as n plus 1 minus 2 factorial. So then I have n plus 1, choose 2, right? And then I'm going to do the same thing here. Plus, this will be n plus 1 factorial over 3 times 2 factorial is 3 factorial. And then I can rewrite this as n plus 1 minus 3 factorial. And then I can do minus ... plus, and then I can have, I'm going to do the same process, right? I'll have negative 1 to the n times n plus 1 factorial over, and see, n plus 1 times n factorial is n plus 1 factorial. And then I'm going to have n plus 1 minus n plus 1 factorial, right? Because I want the n plus 1, choose n plus 1. Okay? And now, this is equal to 1 over n plus 1 times, this is n plus 1, choose 1. This is n plus 1, choose 2. This is n plus 1, choose 3. And then we can go minus ... plus, and then we'll have negative 1 to the n, and it'll be times n plus 1, choose n plus 1. So as you can see, we were able to show that indeed the left-hand side here is equal to this hint here. Now we're going to use this identity here, right? This is equal to 0. So let's go off on a tangent, because of course this here has to equal 1 for the equality to be true, right? So let's go ahead and take a look at this, right? Well, n plus 1, choose 0, minus n plus 1, choose 1, plus n plus 1, choose 2, minus ... plus negative 1 to the n plus 1 times n plus 1, choose n plus 1 is equal to 0, right? That's from up here, right? This here. Okay, so this implies that n plus 1, choose 0, right? If I were to move everything to the other side, is equal to, so this will turn into n plus 1, choose 1 if I add that to both sides. If I subtract this on both sides, it'll be minus n plus 1, choose 2, plus ... and this will be minus. So, of course, I don't want n plus 1, so I can rewrite this as negative 1 times negative 1 to the n, right? Times n plus 1, choose n plus 1, okay? And then n plus 1, choose 0 is, of course, 1, and that's equal to n plus 1, choose 1, minus n plus 1, choose 2, plus ... and this will turn into plus, right? Because negative is positive, plus negative 1 to the n plus 1, choose n plus 1. So look, I was using this here, right? Using this identity, I was able to show that inside of the brackets here, right, is 1. Okay? So thus, I have, let's go here. I'm going to rewrite this here. And choose 0 minus 1/2 and choose 1 plus 1/3 and choose 2 minus dot 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 plus -1 to the n over n plus 1 times n choose n, right? We were able to show that this is equal to 1 over n plus 1 times, right? Times this here. N plus 1, choose 1, minus n plus 1, choose 2, plus n plus 1, choose 3, minus dot dot dot, plus -1 to the n times n plus 1, choose n plus 1. And, right, going on our little detour, we're able to show that this here, right, this here is equal to 1. So this is equal to 1 over n plus 1 times 1. And of course, that's equal to 1 over n plus 1, finishing our proof. We are able to show that this is equal to 1 over n plus 1.